So hello everyone, let's resume the trigonometry episode 2. So today we are going to see this ratio degree table, and there is a trick to fill this table very easily. So let's follow that. First step is to put denominator as 2 in both sine and cos. Yes, we filled the rows with denominator as 2, and now let me tell you the trick. Put root over in numerator and now in sign put 0, 1, 2, 3 and 4, and in cos 4, 3, 2, 1 and 0. So you deduce that the values are 0, 1 by 2, 1 by root 2, root 3 by 2 and 1 respectively, and in cos the reverse, 1 root 3 by 2, 1 by root 2, 1 by 2 and 0. So you all know that tan is a derived quantity which is sine by cos. So for filling the tan table, you like to put the sine value in numerator and cos value in denominator. So it's just a 0 by 1, 1 by 2 divided by root 3 by 2, 1 by root 2 divided by 1 by root 2, root 3 by 2 divided by 1 by 2, 1 by 0. We would end up getting the values as 0, 1 by root 3, 1, root 3 and infinity. So these are the standard values of sine, cos and tan with respect to the degree: 0 degree, 30 degree, 45, 60 and 90. These are the standard values derived. And now I would like to introduce three different more ratios. Those are cosecant theta, secant theta and cot theta. Cosecant theta is 1 by sin theta. Secant theta is 1 by cos theta. Cot theta is 1 by tan theta. You can extend this table once again by cosecant theta, secant theta, cot theta. 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So you all know cosecant theta is 1 by sin theta. So just reverse the put 1 by 0, 1 by 1 by 2 and everything as a fraction, as a reversal inverse fraction. You would end up getting infinity 2 root 2, 2 by root 3 and 1 by 1, which is 1. Same way, secant theta will be the reverse of this. So let's put 1, 2 by root 3, root 2, 2, and infinite. Cot theta will be inverse of tan theta. Let's put the values. Cot 0 will be infinity, root 3, 1, 1 by root 3, and then this would become, since tan 90 is infinite, cot 90 would be 0. So these are the three different ratios, and all these three different ratios are derived quantities, just like as they are derived from sine, cos, and tan respectively. So let's see what are the other identities which we could able to derive from this particular part. We all know that sine square theta plus cos square theta is equal to 1. Dividing both sides by cos square theta plus cos square theta divided by cos square theta equal to 1 by cos square theta, which means sine by cos, you know, tan. So tan square theta plus 1 is equal to secant square theta. Secant square theta minus tan square theta is equal to 1. This is another relationship. Let's put this relationship 1. Let's put this relationship number 2. And there is another relationship which we could be able to derive. Sine square theta plus cos square theta is equal to 1. Let's divide the whole equation by sine square theta. One plus cot square theta is equal to cosecant square theta, which means cosecant square theta minus cot square theta is equal to 1. So these are the three different primary relationship between sine square theta, cos square theta, and all those ratios. So we could be able to derive three different ratios from a right angle triangle, which follows Pythagoras theorem as seen yesterday. And we can deduce whatever we want based on these three equations too. For example, if you want cosecant square theta, you could write it as 1 plus cot square theta. And same way, if you want cot square theta, you can write it as cosecant square theta minus 1. Same way, if you want secant square theta, you can write it as 1 plus tan square theta. And if you want tan square theta, you can write it as secant square theta minus 1. So like that. So now let us see signs of trigonometric ratios. How it behave on a quadratic system, Cartesian system, I mean. So this is a Cartesian system in which this is x and x negative, y and y negative, which means this is positive and this is positive, this is negative and this is negative. It is denoted by a keyword ASTC, which means all silver tea cups. All silver tea cups in the sense if 0 degree, 90 degree, 180 degree, let's name it in degree also, 270 degree. So all silver teacup denotes for all refers to all the trigonometric ratios would be positive in the angle frame 0 degree to 90 degree. Silver denotes sin theta, which means all the values of sin theta would be positive in the time frame of 90 degree to 180 degree. T refers tan theta. Which would be positive in the time frame of 180 degree to 270 degree. And cup denotes cot theta, cos theta, sorry, cos theta, which would be positive in 270 to 360 degree. Here, sin theta refers to sine and its inverse, which means sine and cosecant. Same way, tan refers to tan and cot, and cos refers to cos and secant. This is to be noted. So let's tabulate this so that it would be easy for us. All silver tea cups. Sine and cosecant. 0 to 90 union 90 to 180 degree. Cos theta and secant theta. 0 to 90 degree union 270 to 360. Tan theta and cot theta. 0 to 90 degree union 180 to 270. Hence, this is the behavior of the values being positive in the Cartesian system. So let's see other concepts in next episode. Hope you like this video. Please like, share and subscribe. Thank you.